Welcome to DSD classes. In today's class, we are going to discuss about FPGA and Xilinx FPGA. So the main FPGA means Field Programmable Gate Array. It consists of 4 blocks, CLBs, which are known as Configurable Logic Blocks. Second one is interconnecting wires, routing channels, and third one is switching matrix, and fourth one is IO pads. So CLBs are main heart to the FPGAs. So configurable logic blocks includes digital logics, inputs, outputs. It implements the user logic. So in CLBs we have more number of slices. So in each slice we have a LUT, flip-flop and multiplexer. So LUTs will store the address, flip-flops are memory elements, and multiplexer is a device which will have only one output. So using these interconnecting or routing channels, we connect or it provides direction between the logic blocks to implement the user logic. So like PLDs, we have different input logics, and these are used to implement the user logic. And depending upon the logic, switching matrix, this blue box is a switching blocks which will provide switching between the interconnections. So it will, whatever the switching matrix, it will provide switching between interconnecting routing channels. We can take the logic and it will provide the switching. So to which CLB we have to give the input. So next blocks are IO pads. So these are input and output pads used for the outside world to communicate with different applications. Using this IO pad we can connect IO interfacing. So we can connect input devices and output devices to FPGA with the help of IO pad. So this is the block diagram of CLB. So each CLB's slice has 3 blocks. So first one is LUTs. So these LUTs are 4 or 6 input LUTs. So in these LUTs, so we will store the different operations, and the output of LUT is given to flip-flop or to multiplexer. So flip-flops are storage devices. So we use we have different types of flip-flops, and this is the multiplexer. So, and this is very important concept in FPGA, programmable routing. So we have different routing channels. So this green box is nothing but a switching block. So all the whites we connect to the switching blocks. So between rows and columns of logic blocks are wiring channels. These black lines are wiring channels. These are programmable. A logic block pin can be connected to one of many wiring tracks through a programmable switch. So basically a FPGA is programmable ASIC. So what is an ASIC means? Application specific integrated circuit. So once ASIC is designed, so we cannot modify any program. So if we want to change any program, we can use FPGAs. FPGAs are reprogrammable ASICs. So mainly Xilinx FPGAs have dedicated switch block circuits for routing. Each wire segment can be connected in one of many ways. So in between these we use pass transistors. Using these pass transistors we can provide the logic, right? So commercially FPGAs are Xilinx and Altera. So out of in market 90% of FPGAs will be designed by Xilinx or Alteras. So we have different types of Xilinx, different versions of Xilinx, such as pattern 3, pattern 6. So nowadays we are using Zinc or Vertex 7 Xilinx, and Alteras are Cyclone, Startrix. So these are the some of the commercial FPGAs available in the market. So next is so in our syllabus we have Xilinx Artix-7 FPGA. So mainly Artix-7 device provides the highest performance per watt fabric, and we have different transceiver line rates. Transceivers are nothing but input output serial transceiver lines. DSP processing. So Xilinx has an applications based on DSP processing also, and AMS integration in cost optimized FPGAs. So this Artix-7 featuring the micro blaze soft processor and 1066 megabits per second DDR3 supports. So it supports 1066 megabits. The family is the best value for a variety of cost and power sensitive applications, including software defined radio, machine version, cameras and low end wireless backhaul. So these are the some of the applications of Xilinx Artix-7. So this is the block diagram of layout of Xilinx 7 Artix-7. So this is FPGA. For this we will connect different blocks. So we have 26 pin GPIO and 16 pin. Totally we can connect 26 plus 16, 42 GPIOs. GPIO means general purpose IOs. So these general purpose IOs we can have input devices or output devices, and so basically we have 4 LEDs. So 4 LEDs and 4 switches, 1 clock P and 1 clock N, 100 megapixels clocks also. So clock management is one of the important feature in Artix-7. So we have in Xilinx we have nearly 500 megapixel clocks. So these clocks we have different blocks. Every block depends upon some clock. So if the clock frequency is very high and the processor speed also very high. So these are some of the features of Xilinx Artix-7. So dimensions of 5 centimeters by 5 centimeters. So we use 36 user input and output, 10 analog inputs and 4 LEDs. Out of 4 LEDs, one is red, one is green and 2 are blue LEDs, and 4 user switches. Optical clock IO with MMCX jacks. So clocks will operate and input voltage ranges from 5 volts to 17 volts. See, so the clock frequency is onboard clock frequency is 1000 megahertz and 64-bit configuration memory is 64-bit. Standard Xilinx JTAG header, and with the help of JTAG cable we can connect devices. All GPIOs are directly assembled through 2.4 mm pin headers. Okay, so out of the box functionality, no mother connection required. So these are some of the features of Xilinx Artix FPGA, right? So we have different blocks in FPGA layout. So LEDs, switches, clocks, GPIO pins and JTAG headers. So the main feature is a high performance. It is a high performance Xilinx device FPGA. So FPGA mainly commercial FPGAs are Xilinx and Altaras. So this is the block diagram or layout of Xilinx Artix-7 FPGA. We have 4 LEDs, 1 red, 1 green and 4 blues, 4 switches, 100 megahertz clock frequencies. So power range is 5 volts to 17 volts and different GPIO headers and JTAG header. So thank you so much for it.